Hey everyone, welcome back to another fun and exciting pre-algebra class. Today we are going to continue talking about algebra, and in this lesson we're going to be starting lesson chapter number 4, and we'll be doing lesson number 1 there. That is found on page 139, and in this lesson we will be talking about how to solve an equation. And when you think of algebra, when that's, like kind of that concept comes to your mind, this is typically what students think of when they think of algebra. They think of equations, okay? So x plus 5 equals 10, something like that. That's an equation, and that's what we'll be learning how to solve. So if you have a book, make sure you open there to page 139. This is chapter 4, lesson 1. And if you don't, then make sure that you get out your piece of paper. You need to write some things down. Do these. Be an active learner. What do I mean by that? When you're an active learner, that means that you're actually doing something. You're taking your pencil. You're writing things down as I'm saying them. You have a notebook. You're taking notes. You're doing all those things. So make sure you have a book. Make sure you have a notebook, piece of paper, all those things, and that will help you learn. All right, if you will, go ahead and look down here at the screen, and I'm going to give you some basic steps to solving an equation. And what we're going to do in this lesson is really kind of walk through each one of these separately. So step number 1, when you're solving an equation, you always want to do what you can do. All right, now that sounds silly, and I kind of made that up. So do what you can do. What does it mean to do what you can do? Well, if you have anything that you can distribute, go ahead and distribute. If you have anything that you can add, go ahead and add. If you have anything that you can multiply, divide, do what you can do. Any like terms, combine them. All the things from last chapter that we did. Okay, so we did positive, negative numbers, we did like terms, we did distributing, we did all those things. So if you see anything, you're like, oh, I can distribute, then distribute. Do what you can do. So just take a look at it and say, okay, can I do anything? No? Then you would move on to step number 2. Yes? Then you go ahead and do it. Get everything done that you can do, and then you move on to step number 2. What is step number 2? We want to move the letters to one side and the numbers to the other side. So in other words, we want this to get to the point where we have x equals something, okay? Or z equals something. Or, you could even have something equals x. That's fine too. So your x doesn't have to come first. Your number can come first. That's fine. Sometimes it's better to move the letter to the left side. Sometimes it's better to move the letter to the right side. It doesn't matter which side of the equal sign that you're on. Think about this. 4 plus 1 equals 5 is the same as saying 5 equals 4 plus 1. It doesn't matter which side of the equal sign that you're on, okay? So, sometimes students get all worried about, the x needs to come first. It needs to say x equals. No, it doesn't. It could say 5 equals x. That's fine. No big deal. All right, so that's step number 2. Well, we have some things that we need to kind of keep in perspective here as we're doing that. Like, how are we going to do that? We're just going to start moving letters to the other side? No. Don't start moving letters randomly, okay? So, notice here, it says, remember to keep the equation balanced by using the inverse operation. What does that mean? Well, let's first of all talk about balance. What does balance mean? Okay, so if I have 2 pencils in this hand and 1 pencil in this hand, I'm not in balance, right? So this is heavier, all right? So this is going to go down and this one's going to go up if I'm out of balance, right? So how do I get that to stay balanced? Well, what I would have to do is I would have to add another pencil to this side. So now if I have 2 pencils in this hand and 2 pencils in this hand, now they're balanced, okay? What if I take 1 pencil away from this hand? Well, then I also have to take 1 pencil away from this hand. So I've got to keep things balanced. If I don't keep them balanced, then the equation gets all out of whack, and then you end up getting the wrong answer. So let's take a look at this. I put a picture here of a rock that is balancing 2 other rocks. So you have A couple just interesting things about this. So first of all, this piece right here, this triangle piece. All right. This is almost like your equal sign. Okay. So if you have an equation, this is your equal sign. And what you have is this is, let's say this is the x, and then the equals, and then maybe this is a number. That's the number 7. X equals 7. That's what you're looking for. But sometimes it's not as simple as that. Sometimes you have other things up here, like you have x plus 3. I don't know if you can see that. I think you can. Equals 8, for example. Well, now this side is x plus 3, and it balances with 8. Look, it's balanced right now. But if we just take away, if we just say, oh, I want to just take away this 3 because I want to get it to just the numbers on one side and the letters on the other. Well, look, the numbers are on this side and the letters are over here. So I just took away 3. Well, you can't just take away 3, because what's going to happen to that, if you take away something, this side is going to go up and this side is going to go down. You can't just remove something, because now this one side is heavier than the other side, and now you're not in balance anymore. So watch this. What if I did, let's go back up here and look at this. It says to do the inverse operation. Well, what is the inverse operation? Well, let's look down here, and I've got it written down. The inverse of addition is subtraction, and vice versa. What does that mean? It means that the inverse of subtraction is addition. And then it says the inverse of multiplication is division, and vice versa. The inverse of division is multiplication. So it works both ways. If I want to use the inverse to solve this, here's what I want to do. I want to take this 3 right here, and I want to move him to the other side. Why? Because that's a number, and I want this over here. I'm going to call this my number side, and I'm going to call this my letter side. So I want to take my number over to the other side, and I want to keep my letters together, and I want to keep my numbers together. So if I want to take this 3 over to the other side, notice what I have. I have a minus, or I have a plus 3. I need to do a minus 3. Look what happens on this side when I have a plus 3 and a minus 3. If I have 3 and subtract 3, then I have 0. So now I just have my x left, but the problem is that some students will do this. They'll just cancel that, and then they just say, oh, x equals 8. Because remember, this is your equal sign down here. This is what it's balancing on, is the equal sign. So as soon as I do that, I have to, let's go back up and look at this. Remember to keep it balanced by using the inverse operation. Well, so what do you mean? Well, whatever you do to one side, you have to do to the other side as well. So whatever I did on this side with the inverse operation, I also need to subtract 3 from this side. So that's going to give me 8 minus 3 equals, and the answer over here is 5. So in this case, x equals 5. And now my balance is still there. Why? Because I had 3 on one side. So I can't let it get out of balance. So I have to take it away, and then also take it away from the other side to keep it balanced. Algebra, the word algebra means balanced. It means it's an Arabic word, and it has the idea of keeping something in balance. That's what we're doing. That's the goal. And then the last one here, we want to check our solution. Look at number 3 here. Check our solution by plugging it into the original problem. All right, so the original problem here was x plus 3 equals 8. Our solution was this 5 right here. So we want to take that 5 and we want to plug it in for the x, because we just said that x equals 5. That's what we just said. So now let's see if that's actually true or not. So we say now, instead of x, we say 5 plus 3 equals 8. And look, 8 equals 8. We checked it. It works. We're good. So the way that you check these is you take your answer that you got, x equals, whatever, and you plug it back into the original, and it should give you, 8 equals 8, 10 equals 10, 5 equals 5, whatever. How do you know you're wrong? How do you know you did something wrong? Well, if you get something here that says like 8 equals, let's say it was 10. 8 equals 10. Well, it's wrong. Okay, 8 does not equal 10. Or, better yet, maybe we say on this side, since this is 8 over here, we could say 10 equals 8. So if we get something like that, we know we did something wrong, and we've got to go back and fix it at that point. But on the one that we just did here, we did get 8 equals 8, so we were good. All right? Now, let's go ahead and skip down. Let's do one more. So remember, this equal sign is kind of like our balance, that the whole thing is balanced on, okay? So I'll put that triangle there. Hopefully that can help you remember. Now, let's go through our steps. So let's go back up here and let's do what we can do. All right, well, that's step number 1, do what we can do. Well, let's see. Let's take a look. Can we do anything here? X plus 5, I don't know what x equals, so I can't add x plus 5. I can't do anything there. How about on this side, 10 plus 5? Oh, I know the answer to that. So all you do is rewrite x plus 5 on the one side. You can't do anything there. And then you just solve that out. What is that? It's 15. Okay? And now we get to the point where we can't do anything else. There's no more do what you can do. There's no more distributing. There's no more combining like terms. There's none of that. So now we have to do what? Get the letters to one side. So let's call this the letter side. And let's call this the number side. So we need to take this -5 right here, and we need to move him to the other side. How do we move him to the other side? By doing the opposite sign. What is the sign? The sign is adding, so we're going to subtract 5. If we do it to one side, we must also do it to the other side. You will hear me say that about 1,000 times over the next few weeks and months as we go through these equations. If you do it to one side, you must do it to the other side. So guess what happens here? This cancels. If I have 5 and take 5 away, I get a cancel. That's what I wanted. Why? Because I want x to be by itself. So look, x equals, there's our equal sign. And then we just do this math right here. 15 minus 5 equals 10. Okay, so x equals 10. Now how do we check that? So plug it back in here and let's see what we get. 10 plus 5 equals 10 plus 5. Well, yes it does. So 15 equals 15, and we checked it, and we are correct. Notice I put down a little reminder here, and we should know this, right? If a number does not have a sign in front of it, it's positive. Okay, for example, this 10 right here is a positive 10. You could actually put a plus sign right there. Yeah, absolutely. Any number or any sign, this x is a positive x. So if you ever have to move something that doesn't have a sign, it's always positive. So how would I move this? Let's say that I want to move this x to the other side, and I can. I would have to subtract x from both sides. And you might say, well, looking at it like this, you might say, well, I don't know how to move that. I don't know how to move that x to the other side. Well, if it had a positive sign in front of it, then you would say, oh, I'd just do a negative x. So remember that if it does not have a number in front of it, then it is positive, always. That will help you a lot when you're doing these. That's something that I would write down, right? I say something, I'm like, hey, here's a hint, here's a life hack. You might want to write that down. And some of you are like, write what down? Okay, scroll the video back right there and write down what I just said. That's going to help you. And so always try to be writing things down when I tell you things that like that, because that's like a really important thing that I've seen a lot of students mess up on over the years. So, try to be smart right there and not make the same mistake that others have made. All right, so here we go. We are going to try to solve this. Well, let's follow the steps. Step number 1, let's go back up here. Do what you can do. Well, let's see. Can't do anything. Nope. And nope. So can't do anything. So I go to step number 2. Move the letters to one side and the numbers to the other side by doing the inverse. Okay, let's try it. So we have this right here. That's what we want to move over here, right? Because we want to get the letter all by itself over here. So this is the letter, this is the number. So how do I move this negative 10 over here? Well, what's the opposite of negative 10 or subtracting 10? The opposite is adding 10 or positive 10. If I do it to one side, you got it, then I have to do it to the other side. So I have to also do it over here. Look at what happens here. 10, positive 10 and a minus 10, they cancel, and I get x equals, and then I just do this math. The answer would be 20. Now let's check it. That's our last step. So I would take that 20 and plug it back in. So I would get 20 minus 10 equals 10. Is that true? Yes, it is. 10 equals 10. I am correct. All right, here's another one, and now we are going to start adding in multiplication and division. It's no different. It's the same thing. We just do the opposite, or what we call the inverse sign, and just work your way through it. So step number one, do what you can do. Check this out. I can do that. Okay, I don't have to move anything. I don't have to, get x by itself. I can do that. Because they're like terms, they're both constant terms. It's just two numbers. I can add them together. So what do I get? X over 7 equals 12. Okay. Now, what is this fraction? This fraction is division, right? So if I'm dividing by 7, how do I get rid of that? How do I get x by itself? What's the opposite of division? Well, it's multiplication. If I multiply one side by 7, guess what I have to do to the other side? I also have to multiply the other side by 7. Notice what I can do, and I can do this as a fraction, right? Since this is a fraction, I just put it over 1, and that's going to cancel to a 1, and that's going to cancel to a 1. I'm going to get 1x, and I don't have to write 1x. I can just write x. Okay, so either way, 1x and x are the same thing. So if I have one apple or if I have a apple, it's the same thing. So if I have 1x or nx, it's the same thing. So 1x is the same as x. Equals, what does it equal? Well, it equals this. So you just have to do that multiplication, and you would do 12 times 7, and you would get 84. Okay? Now, what you do is you plug it back in. All right, so I take my 84 and I plug it back in where the x was. So now I have 84 over 7 equals 9 plus 3. 84 divided by 7 is 12, and 9 plus 3 is also 12, and so it checks, and I am good to go. All right, let's do one more here real quick. And I like this one because I'm going to show you two different ways to do this real quick here. Notice that this is like saying 3/4 times x, right? Because there's no sign in there. So when there's no sign and you have your letters and your numbers just crunched together, that means it's a multiplication problem. So watch this. If I can do this two different ways, and here's what I'm going to do. If I'm multiplying by 3/4, then I need to divide by 3/4, and I need to divide both sides by 3/4. What happens here is I get a cancel. Now let me show you that just in case you don't believe me. Remember, 3 over 4 divided by 3 over 4 actually means that we have 3 over 4, and then we have to flip the second one, times 4 over 3, right? We change it to multiply, flip the second one. That's the way that you do fractions. And we get cancels everywhere. We get 1 over 1, or we get 1, okay? Or 1x. So every time you do this, this is called the inverse right here. So every time we do the inverse, that cancels, it goes away. So we are left with x equals this. What is this? Wow, look at that. Well, it's not hard, okay? Just write it out. 27 divided by 3/4. You know how to do that, right? Put 1 over that, and now we have to invert the second one. So we'll take this 3/4 and we'll make it 4/3. And we take the multiply or the divide, and we change it to multiply. Okay? And then we just go ahead and do that. Look, I can cancel here to a 1. That cancels to a 9. And so now I just have 9 times 4, and that gives me 36 over 1, or just 36, and that would be my answer. Okay, now how do I check that one? Same way I've checked them all. Okay, I just go back up here and I say 3/4 times 36 over 1 equals 27. Well, let's see if it does. 4 cancels to a 1, that cancels to a 9. 3 times 9 is 27, equals 27. It does check out. Now, I told you I was going to show you a second way to do that one. And I know this is a little bit longer lesson, but I think it's important that you understand this, so I want to take a little extra time here. All right, so back here to the beginning of this problem, and let me show you a different way. You could say, look, this is divided by 4, right? Because that's what's happening right there, is it is being divided by 4, all right? So you could actually say, I'm going to multiply this by 4 to get rid of it. Yeah, cancel, cancel. Now look what I have, 3x equals, multiply that out. Well, you 27 times 4, 28, and 4 times 2 is 8. That gives you 108. And now look, now I have a multiplication, 3 times x, so I would divide that by 3. I also have to do it to the other side, so I have to divide this by 3. This is just an extra step, but really it's doing the same thing as when we divided by 3/4. Now we're just doing it in separate pieces. So look here, that cancels. 3 divided by 3 is 1, or just 1x, or just x. X equals this. What is this? 108 divided by 3. 3 goes into 10 3 times. 9, 1, 18, and I get 36. There's my 36 again. Okay, so I get the same answer no matter which way that I do that one. I can do it either way, and I come up with the same answer. So make sure that you're remembering our steps. Let's go back up and look at our steps again. Step number 1, do what you can do. So just do any addition, subtraction, combining like terms, distributing, anything that you can do. And then step number 2 is you start moving the numbers to one side, the letters to the other side. Step number 3 is you check your solution by plugging in. Make sure you remember these inverses. What does the inverse mean? The opposite sign. So inverse of subtraction is addition. Inverse of multiplication is division, and so on. And so, yeah, go ahead and try that. Try some of these. Practice makes perfect, right? So work hard, and if you missed anything, slide it back and watch that again so that you can get these right on your practice problems, okay? We'll see you later. Have a good one. Bye-bye.